In level 4, there are two problems you should know how to do. One is the shortest distance from a point to a curve, and the other is that rectangle problem, the maximizing the area of a rectangle under a curve. So I'll go through an example of that one too, even though it's not on here. But first we're going to go through the shortest distance from a point to a curve. You have a calculator for these. It's a calculator application, so if you don't know what the graph looks like, you can always graph it in your calculator. But we should know what the graph y equals natural log of x minus 1 looks like. It's a natural log graph shifted 1 to the right, so it looks kind of like that. And the point negative 1, 1 is somewhere over here. And we want the shortest distance from that point to the graph. So what is the shortest distance that could be? And we have some mystery point on the graph that is the closest point to negative 1, 1, some xy pair. And we are going to represent this distance using the distance formula. Remember, if you have a pair of points x1, y1 and x2, y2, you can represent their distance by doing the square root of x1 minus x2 quantity squared plus y1 minus y2 quantity squared. So my points here are x1, y1, and x2, y2. But I want to only have this be in terms of one variable. So I want to replace y with an expression for y in terms of x. And so since this mystery point, this xy pair, is on the curve y equals natural log of x minus 1, I can replace y with the function natural log of x minus 1. So I'm going to erase that y and instead use natural log of x minus 1. That's an expression for y in terms of x. And now I plug that into the distance formula, and I get the square root of x minus negative 1. You can change that to x plus 1 if you want, quantity squared, plus my y1 is natural log of x minus 1, and then minus 1, quantity squared. Side note, you cannot combine this minus 1 with that minus 1 because the expression inside the log can't be combined with something outside of the log. So you just leave it like that, and you turn on your calculator, and let's see. Okay, so on the calculator you're going to go to graph, and you clear whatever's in there. I've got some stuff in here already. And so we go tab, and we enter our distance equation. So I start with a giant square root, and then parenthesis, x. I can change that to plus 1 if I want, or I don't have to. And then I square the outside of the parenthesis, plus another parenthesis, and then I do natural log. I have to press Control and then the E to the X button. Natural log of x minus 1, and then on the outside of that parenthesis, minus 1. And then I go to the outside of that parenthesis and square it. Press Enter. And there's my function. I'm going to pinch it, if I can find my little hand. Hold on. I just escaped because I couldn't find my hand. There it is. Okay, so there's the function. You can make sure it's entered correctly. I'm going to move it down here so it's not in my way. Now to minimize this distance, I want the shortest distance. I have to find the minimum point. So I go Menu, Analyze Graph, and minimum. And then when it says lower bound, I need to be to the left of the minimum point, and then upper bound, I need to move to the right of the minimum point. And then I click, and it gives me the minimum point of my distance function. So my distance function looks something like this, and its minimum point is 1.59 approximately for the x and about 3.01 for the y. Okay, now since this graph represents distance, the shortest distance is the y value of that minimum point. So 3.01 is the shortest distance between the mystery point and -1, 1. But the other question is, what's the closest point? And the closest point we find, well, first of all, the x value right here is it came from the x value of that graph, or that point that our mystery point. So the x value of the closest point is going to be 1.59. And then the y value is the y coordinate that goes with the x coordinate on your natural log graph. So to find the y value that goes with it, we plug our x into the function y equals natural log of x minus 1. So y is going to be natural log of 1.59 minus 1. And so we can do that in our calculate window. Natural log of 1.59 minus 1, and I do Control Enter to get a decimal approximation, and I got about -0.53. So the closest point is going to be 1.59 -0.53. That's my mystery point on that graph. And this problem is not in the notes, but I wanted to do the area of the rectangle problem too, just in case anyone's still confused on that. So if you want to find the dimensions of a rectangle with the greatest area bounded by a certain graph and certain axes, first you want to figure out what the function looks like. If it's not graphed for you, you can graph it in the calculator. This one's already graphed for us. But this time we want the rectangle to be bounded by the negative x-axis, the positive y-axis, and the curve. So we've got a rectangle somewhere in here, and we want this rectangle to have the greatest area possible. And so we're going to be graphing this in the graphing calculator, but we need to write a function for the area of this rectangle. Now, the x value right here times the y value right here will sort of give you the area, but remember that the x values are negative to the left side of the axis, so technically we're going to get negative areas if I just did x times y. So to counteract that negative x value, for my area function, I can just put a negative sign in front of that x, which will change it to positive. So normally the area is just x times y, but I'm going to write this in terms of x, and I'm going to put negative x, so I get the opposite of the x values. And then the y values, I need an expression for y in terms of x. And remember this point on the graph, this xy pair, I can express those y values in terms of the function. So it says y equals 4 minus 3e to the negative x minus 5. I can replace y with that expression. And I do that in my area equation. So instead of y, I use an expression for y in terms of x. 4 minus 3e to the negative x minus 5. And now I graph that in my graphing calculator. So I go to graph. I delete my last problem. I go to tab and I enter x, or this time negative x, times parenthesis 4 minus 3 e, and I used my e to the x button, to the negative x minus 5. And then I hit enter, and I get positive values for my area. I'm trying to find the maximum area, so I can't see the top of the graph. I need to change my window. So I'm going to go to window settings and make my Y max a little higher. I have it set at 10, so it looks like I'm almost at the top. I'm going to change that to 15. And now I find the maximum point. So menu, analyze graph, maximum. I go to the left of the maximum point. I click, I slide over to the right of the maximum point, click, and it gives me the maximum point. So this is my area graph. This time the maximum point is over here in quadrant 2, and the maximum point is negative 3.73, and the y value is 11.78 approximately. Okay, now remember that this graph represents area. So the maximum area is the y value, 11.78. Now if you wanted the dimensions of the rectangle with the greatest area, you're going to take the x value, and that is negative 3.73. And then to find the y value that goes with it, I can plug that x value into the function. So I go to my calculate window, and I take for the y value, I'm plugging it into my original function to find the y value that goes with it, 4 minus 3 e to the negative, and then I plug in negative 3.73. So negative x minus 5, and I plug that in my calculator. 4 minus 3 e, oops, that's not what I want, e to the negative, and then I'm going to put a parenthesis, because remember there was a negative in the equation, and then my x value that I'm plugging in is negative, so negative 3.73. I'm going to go out of that parenthesis, minus 5, but I'm still in the exponent. And then I press enter, and the y value is about 3.16. So the dimensions would be, well, technically the dimension of a rectangle should not be a negative value. So the dimensions of the rectangle, the final answer here, would be 3.73 by 3.16, because side lengths of rectangles are always positive values, just like area is always a positive value.